Hi everyone, welcome back to the Fundamentals of FSP Lab with the Renaissance RA8 series. Today we will continue building on our project. After setting up the tools, creating a project, and exploring the FSP, we are now going to add the timer module to blink an LED. Let's get started. Our goal now is to make the board blink the LED marked LED3 every 250 milliseconds or quarter of a second using the general PWM timer. Once the timer is set up, it will run automatically and call our code on each tick. Open configuration.xml and switch to the Stacks tab. Make sure you are on Hall Common. Then click New Stack. Under the Timers category, select General PWM. In the Properties window, set Channel to 8, Mode to Periodic, and Period to 250 milliseconds. Enter G_timer0_CB as the callback name and set the interrupt priority to 5. The tool automatically names this instance G_timer0. If you add more timers later, there will be G_timer1, G_timer2, and so on. Click Generate Project Content to apply the changes. This updates the generated code with our new timer configuration. Now, open hullentry.c. At the top, we will add a macro for error checking called AppAssert. This will help us catch and halt the program if any API returns an error. We'll also add a global counter variable G_counter so we can track how many times the CPU wakes up from sleep. Next, let's create the timer callback function. In the Project Explorer, open Developer Assistance. Find GTimer0 under Timer General PWM and scroll to the callback function definition. Drag it into the hullentry.c window. This tool inserts a function prototype and an empty body for us. Inside this callback, we will toggle the LED3, the red LED. We can find its pin in the board's schematic, or faster, check the Pins tab. Pin 107 is connected to LED3, and in our config, it has the symbolic name LED3. Using symbolic names makes your code more readable and portable. In the callback, we will create a static variable called level. Static means it keeps its value between calls, so the LED stays in its last state until the next tick. We will call RIPort pinWrite to set LED3 to the current level. Then flip the level for next time. Back in hullentry function, declare a variable of type FSPRT to store return values from the FSP APIs. First, call rgptopen with the timer control block and its configuration. Then check the return value with AppAssert. Next, call rgptstart to start the timer, and again check the result with AppAssert. The AppAssert function that we have defined will bring the program to a halt if the previous API call fails. Now, we will add the main loop. Inside while1, we will call WFI, wait for interrupt, which puts the MCU to sleep until the next interrupt. After waking, we will increment G_counter so we can monitor the MCU is running our code. Build the project to make sure there are no errors. Connect to the board to start a debug session. If this is the first time, you may be prompted to update the J-Link firmware. In that case, click Yes. The debugger will stop at main. Click Run to start the program. You should now see LED 3 blinking every quarter of a second. Okay, let's test our callback. Open hallentry.c, go to the gtimer0cb function, and double-click next to the RIO port pin right line to set a breakpoint. Run the program. The LED will stop when the breakpoint hits. Continue to let it blink again. To watch the CPU activity, open the Expressions tab, drag in G counter, right-click on it, and enable a real-time refresh. Run the program. You will see G counter increasing even though the CPU is mostly sleeping between timer interrupts. And that's our timer in action. LED 3 blinking consistently and the MCU only waking briefly to toggle it before going back to sleep. We have seen how to create an empty project and add the first module. In the next episode, we shall add more modules to this project to enhance the functionality. See you next time.